Teacher, hello teacher. This video will be uploaded late because my laptop is I don't know stopped to work, so I will explain very fast in my paper in paper. So we have PT graph. We know this given is 2 multiplied by 10 to the power of 5 Pascal gas. Here T is 100 Kelvin and 300 Kelvin. Okay, and there is a process from 1 to 2 and 3. Let's find work from 2 to 3. We know it's a dV equals to P dV. Here T is constant. T constant. And but P is not constant. Therefore, we'll write the formula to P that it equals to nRT over V delta V and integral. We took integral on both sides. So integral will be equal to nRT ln V. Here's from V2 to V3, yes? And it will be V3 over V2. It will be minus, and when minus, it will be divided in logarithm. T is we can take T2 or T3. It's same, yes? Okay, V23 equals 2, and it's 1 mole. It's 8.31. T is 300. Ln is, if we find V3 from an ideal gas formula, it's nRT over P3. And V2 is nRT2 over P2. We can put these formulas and it will be P2 over P3. And here will be just ln2. And if we will calculate it, we will have, if I'm not mistaken, 1789 joules. This is our first answer, first work. So okay, from V3 to 1, from 3 to 1, here's a pressure constant, P constant, and P delta V is formula. If you'll take integral, it will be P is not changing, so P, and it's just the integral of dV is the V. It means V1 minus V3, yes? Okay, V31 equals 2. We also can put here formulas like nR T1 over P minus nR T3 over P. Why I wrote P? Because here's P is same. And if we will take under brackets nr over P, P will be cancelled. It will be just nr multiplied by T1 minus T3 in brackets. T1 is 100, T3 is 300, and V3 to 1 work will be minus 1662 minus 1662 joules, minus because the volume is decreasing. So, and important part is from 1 to 3. Okay, let's draw graph again. Here's from 1 to 2, and it begins at some point, not from 0. At some point T0, some temperature. Here's a T 100, here's a 300. Here's 10 power 5, here 2 multiplied by 10 power 5. So let's take some point here. It's T, it's P, some point T in graph, and at some point here V. And we know that it's linear graph, and the alpha at every point will be equal each other. And let's write tangent alpha formula from triangle to these triangles. For example, for this medium triangle. Here PT, the opposite will be P, the adjacent is T minus T0, because it begins from T0. Tangent alpha for this big one triangle is opposite is T2 multiplied by 10 power 5 over 300 minus T0. Tangent alpha for the small one is not 100, 10 power 5 over 100 minus T0. So we get this 3 times alpha, and let's find the T0 equalizing these two formulas. Here will be 2 over 300 minus T0 equals to 1 over 100 over T0. Here will be T0 will be equal to minus 100 Kelvin. It means that it will begin some here at some this point. minus 300 on what in minus 100. Okay, we find t0. Let's equalize these two formulas and find pt formulas. Okay, here will be plus 100 over, let's take this, and here will be 2000. Yes, 100 plus 100, and here we can find that p, yes. Let's put to pt formula from ideal gas, pv over nr. If we'll put it, we'll get that p will be equal to minus 845 over v. If we'll calculate this everything, we find the зависимость from p to v. Why we need it? Because we know that delta v work equals to p delta v. If we found the direction directly formula from p to v by using these geometric formulas, and by taking integral, here will be minus 845 over v delta v, yes, and from what? From v1 to v2, from v1 to v2, and integral of this will be ln, yes. So minus 845 multiplied by ln v2 over v1. So if we'll calculate it, v2 is here, v1 is nRT1 or p1. If we'll put these numbers, yes, ln v1 over v2 over v1, the here nothing is a constant, so let's calculate it.